Let's now read through this summary of the maximum flow being equal to the minimum cut. So this is a summary of the minimum cut method. And again, it might not make 100% sense until we see some more examples, but it's very important that we read it through together. Okay, so what is the minimum cut? Used when the weighted graphs become more complicated, based on the concept that the maximum flow is equal to the minimum capacity. A cut is a line passing through a network, cutting it in two. It must separate the source from the sink. So that is a key definition of the cut. It must separate the source from the sink. The cut capacity is the total capacity or weighting of all the edges that all the edges that the cut passes through. It is calculated by summing the capacities of all the edges crossed by the cut. The minimum cut of the network is the cut with the smallest capacity. The capacity of the minimum cut is equal to the maximum flow of the network. So very important, the capacity of the minimum cut is equal to the maximum flow of the network. Note, if an edge flows from the sink endpoint side of the cut to the source, the start point side of the cut, it's not included in the summing for the final capacity. This little note here is kind of hard to understand until we see an example, so you're just going to have to hold on for me for that little note. Okay, let's continue. Edges are cut off so that there are now no possible pathways from the start to the end. The capacity of the cut is the sum of the weights of the cut edges that affect the overall path, excluding edges that flow from the sink side of the cut to the source side. And again, this little line here will make more sense once we see an example. The minimum capacity cut will equal the maximum flow. It's best to start with two main cuts to determine the upper limit and minimum value to beat. So let's read that again. It is best to start with two main cuts to determine an upper limit and minimum value to beat. Okay, so this summary is not going to make 100% of sense until we now jump into an example. So let's now do that.